Here we have the power series of x minus 2 to the n minus 1 dividing by 2 to the n minus 1, and we want to find the interval of convergence, meaning we want to find the set of x values for which this power series converges. And so again, we'll use the ratio test. And so we'll use the button this part right here. And so use the button plus 1. Then in the place of n, we just put n plus 1. So for that n, we have n plus 1. And then for this n, we have n plus 1. So this right here becomes this. N plus 1 minus 1 is just n. And then right here, same thing, it's just n. And then now we need the ratio of u sub n plus 1 dividing by u sub n. So u sub n is this. And then u sub n, this is u sub n plus 1, and then u sub n is this. So let's simplify a little bit. X to the x minus 2 to the n minus 1, this is the same as x minus 2 to the n times x minus 2 to the negative 1. And then 2 to the n minus 1 is the same as 2 to the n times 2 to the negative 1. And so now this becomes this. So we have that, and times the reciprocal of this. Remember that dividing by fraction is the same as multiplying the reciprocal. So the reciprocal is going to be that dividing by this. The x to the x minus 2 to the n will cancel out with this. The 2 to the n will cancel out with this. So for the top, what's left is 2 to the negative 1 and x minus 2 to the negative 1. So one more time, this x minus 2 to the n will cancel out with this. And then 2 to the n will cancel out with this. And then, now this is a negative exponent, and so we move it to the denominator, then the exponent becomes positive, and then this is the same thing, this is x minus 2 to the negative 1, so we move it to the top, then it becomes positive. So now we have x minus 2 to the first, and then on the bottom we get 2 to the first. And so this is just x minus 2, and then the bottom is just 2. So that's what u sub n dividing by u sub n plus 1 dividing by u sub n. And then now we need the limit as n approaches infinity. So the limit and so now we need to set, since we're looking for x for which the power series, well, we're looking for all the x values for which the power series converges. So we will set this right here to be less than 1. Because for ratio, remember that for ratio tests, regular infinite series converges if the limit is less than 1. And here we're looking for all the x values for which the power series converges. And so that's why we set it to be less than 1. Now here the limit is with respect to n, but there's no n here. And so we have just this. But what this means is this: absolute value of something less than 1, it means that that something is between -1 and 1. So that's what it means, absolute value of an expression less than 1. Then that expression is just between -1 and 1. And now multiply everything by 2, we get -2. -1 times 2 is -2. And then multiply this by 2, we get x minus 2. And then multiply the right side by 2, we get 2. And then now add 2 to each part, the left, the middle, the right. So we add 2, we get 0. Here we add 2, we get x. And then here we add 2, we get 4. So now we know that the power series converges for any x in the interval between 0 and 4. And then to get the interval convergence, we also need to check 0 when x is 0 and when x is 4. So for x equal to 0, then in the place of x, we put 0. So this is the power series right here. And so in the place of x, we put 0. So we get 0 minus 2, which is -2. So we get -2 to the n minus 1. And then the bottom is 2 to the n minus 1. But -2 to the n minus 1, -2 is the same as -1 times 2. And then we can separate the -1 and the 2 like this. So this is the same as -1 to the n minus 1 times 2 to the n minus 1. But the 2 minus n, these two were cancelled out. And what's left is the summation of -1 to the n minus 1. This summation right here, when n is 1, then we get 1 minus 1, which is 0. -1 to the 0 is just 1. When n is 2, then this would be 2 minus 1, which is 1. So -1 to the first is -1. When n is 2, we get 2 minus, when n is 3, we get 3 minus 1 is 2. -1 squared is 1. So this summation right here is just going to go 1, -1, 1, -1, 1, -1. If we add the first two terms together, we get 0. And then if we add the next term, we get 1. At the next term we get 0. At the next term we get 1. So this summation right here is just going to alternate between 0 and 1, 0 and 1, 0 and 1. So it diverges. And so when x is equal to 0, the power series diverges. And now we need to check 4. So when x is 4, and this is the power series right here, in the place of x, we put 4. 4 minus 2 is 2. So we end up with 2 to the n minus 1. But 2 to the n minus 1 and 2 to the n minus 1 dividing by 2 to the n minus 1 is 1. And then this summation right here means 1 plus 1 plus 1 plus 1 forever. And therefore it's infinity. And so when x is 4, the power series diverges also. And therefore the interval of convergence is just between 0 and 4. And so the power series converges for any x between 0 and 4, not including 0, not including 4. And so what it means is that if we let x be any number in this interval, the power series converges. And if we let x be any number outside of the interval 0, 4, the power series diverges.